All right, let's talk about classifying triangles first. 23rd lesson of the semester. So we've done quite a bit of stuff here. Still got a lot to go. So classifying triangles, all this stuff you should know already. So we're going to kind of move fast. When a triangle has three acute angles, it's an acute triangle. And we're just going to use a picture of a triangle instead of writing out the word triangle. If it has one obtuse angle, it's a obtuse triangle. Yeah, super easy stuff. One right angle, it's a right triangle. Three congruent angles, equiangular. Equiangular. So we're classifying by angles in this first little set here. All right. So classifying by angles. Let's look at this picture here. There in that diagram below that. We're going to use the diagram to classify each triangle by its angle. So we're classifying by angles here. Triangle CDE. CDE is right there. It is a right triangle. It is a right triangle. Okay. Triangle BCE. Obtuse. Angle C there is an obtuse angle, so that's an obtuse triangle. Triangle ABE. Equiangular. Technically, yes, it is an acute triangle because all of those angles are smaller than 90 degrees, but because they're all equal, then the equiangular is a stronger relationship in that triangle. So equiangular is the one you would go with. Triangle BDE. Obtuse. Yeah, that angle right here with E is obtuse. So that's an obtuse triangle. And CFE. That one is an acute triangle. Easy stuff. Easy stuff. All right, it's classified by sides. So three congruent sides. Equilateral. Two congruent sides. Isosceles. ISOCELES. Isosceles. Or I forgot there's an S in there. Isosceles. 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 No congruent sides. What? No. Scaling. All this stuff you guys have heard all this stuff before. Do a lot of this, I think, in junior high math now. So a lot of the classifying is all done before. So looking at the diagram, JKM. JKM. That would be a scaling. KLN. Look at your marks. KLN. These two are congruent. The third one is not, so that is isosceles. And then JKN, all three have the same mark on them, so that is equilateral. All right. So in the practice there underneath that, it says classify each triangle by its angles and its sides. So we're going to do both. So number 9, right isosceles. It has two congruent sides and a right angle in there. Obtuse. Scaling is right. Good job. Because we don't have any marks that tell us the angles are the same or the sides are the same there. Equal angular. Equilateral. Number 12. Acute scaling. Job. 13. Yeah. No marks there to tell us any of the sides are the same, so we've got to assume that they're different. Scaling. 14. Obtuse isosceles. Good job. Easy stuff. All right. Much more complicated looking picture there. That's the fun part. And it says if segment PR bisects angle SRT and U is the midpoint of RT, classify each triangle by its angles and sides. So we're getting a little information that kind of bleeds back to the things that we've done before of that stuff. So if PR bisects angle SRT, what do we know about this angle and this angle? They're congruent there because of angle bisector. The definition of angle bisector, that's what we know about that. So we know that that's a 30-degree angle there. So if this one here is 30 degrees, then that one has to be 30 degrees. And then it says U is the midpoint of RT. U is right here. RT is that side. So what do we know about the length from U to T? Yeah. Which is 8 meters. Those are congruent to one another. So then we get some other stuff about it. Yeah, you're right. Some dominoes are falling because of those things. All right, so they want us to classify by angles and sides triangle UQR. 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 I'll highlight UQR. That triangle right there. Obtuse isosceles. Good job. Obtuse isosceles. Triangle RST. Equal angular and equilateral. Y'all agree? I hope so. That's right. Easy stuff. SRQ. Right and scaling, yeah. Triangle PRT. It's not equilateral. It's obtuse because this angle T right here is an obtuse angle. It's 60. Obtuse isosceles is the right thing. Number 19. There, TQU. Try a little. Go for something stronger. How do we know it's equal angular? Even though we only have one angle that's written in there, but what can we do to find the rest of it? We don't have that yet. We can do it without that. linear pair right there. Good, good. And then so that makes that 60. And then we know that this one's got to be how much? 30, because those are equal. That's isosceles, right? And that makes those angles the same. And then if this is 30, what does this angle, these two little angles right here have to be 90 to be that linear set there. So that's how we can get that 60 without doing the 180 thing. So you get those answers without using that 180 theorem for angles inside of that. So equiangular and equilateral. Equilateral. And last one, PQT. What do we know about this angle right here and this angle right there? They're vertical angles, yeah. So those are right angles as well. So it's got to be a right triangle. How would you be able to tell it's isosceles? Or there's not a line. So does this side look like it's the same as that side? I don't think so. I'm just going to say scalene because I don't have anything that would help me find the length of that side. Well, I actually do. I could do Pythagorean Theorem because it's the right triangle. We know Pythagorean. I guess that you can consider that general knowledge. Now you could do a squared plus b squared equals c squared. So 16 squared is 256 minus 64. And then the square root of that's not 8. So we know it's not isosceles. So it's got to be scalene. All right. So a little bit more complex picture going on. That's the, kind of the next level. The previous examples were really junior high because they were single pictures. Let's look at these, a little bit more of combining some things we've done in the past. So on the coordinate plane, so this is what we call coordinate geometry. We don't actually have to graph these. We can do all the work without graphing it. It asks us to find the measures of the sides of angle JKL, then classify it by its side. So how do we find the lengths of sides? The distance between points. So distance formula. Do we know the distance formula? We should. X1 minus X2 squared plus Y1 minus Y2 squared, all under the square root. So we've got to find 3 side lengths. So we're going to find from J to K. So -7 minus -9 squared plus -7 minus 1 squared. So that's going to be 4 plus 64 would be 60. Square root of 68 is from J to K. And then I'm going to do from K to L. So -9 minus -1 squared plus 1 minus -1 squared. So be -8 squared 64, negative or +2 squared is 4. So that's again square root of 68. So far it's at least what? If 2 sides are congruent, what is it? Isosceles. If the other side is also square root of 68, what would it be? Equilateral. So we find the last side, which would be from J to L. -7 minus -1 squared plus -7 minus -1 squared. That's going to be 36 plus 36 square root of 72. So it's just isosceles. So we're classifying by sides. Two sides congruent, isosceles. All three sides congruent, it's equilateral. If none of the sides are the same, scaling. Those are the three options. All it takes is doing distance formula. Okay, I'm not going to bore you with going through 5 examples of distance formula problems. You guys can do that. It's just mechanics of it. So make sure that you know the distance formula. Let's get to what you guys like better, algebra. Yay, everybody likes algebra better than other things. Okay, so solving with algebra, if we know the sides. So here it tells us the triangle ABC is equilateral. It wants us to solve for both x and y. So if we know it's equilateral, what do we know about all sides? They're all equal to each other. So if we know that side AB is 49, then side BC has got to be 49. So we just set up 3x plus 1 equals 49. Solve that. X is 16. And set up the same problem with the bottom side AC and set it equal to 49 as well, because we know that all the sides are equal. We have the measurement of one of them. So just set that problem up. That'd be 18y is equal to 90 and be 5, wouldn't it? Easy stuff. Y'all like algebra a lot better. I gathered that.
So on this one, you just set them equal to each other, right?
Okay, yeah, you could set any pair equal to each other because it tells us it's equilateral, and find the measure of x and the measure of each side. So it doesn't matter which ones you set up, though. You pick your poison there. Which ones y'all want to set equal to each other? Okay. Got more than one person doing that, so we'll just do that. So that'd be 2x is equal to 16. X is 8. Then plug that in, and each side is going to measure 80 minus 6 is 74. And we don't have a unit on that, whether it's feet, meters, or inches, or anything like that. Just put 74. If it doesn't have a unit, then you don't have to put the unit there. But if it has, it's in feet or meters or something like that, then you need to use that. Okay. Should have gotten if you want to check that, you could set up a different equation and solve it. You should get x is 8 anyway, no matter which pair you put together, because it's equilateral. So you just pick which one you want. Number 3 is also equilateral. Find x and the measure of each side. Do the same thing, right? Yeah, that's what. We set those two equal to each other. 3x equals 39. X is equal to 13. And then 13 plus 14 is 27. Whatever. Meters, feet, something. Easy stuff. All right, let's get to number 4. It's a little bit different. It says if triangle DEF is an isosceles triangle with side DE and side EF congruent to one another, find x and the measure of each side. So what do we have to do on this one? Yeah. It'd be 3x is equal to 30. X is equal to 10. Yeah, so I'm going to plug that into 5 times 10 plus 17, 67. So what sides equal 67? And then we need to find side DF. DF would equal 31. Just plugging that in mentally there. There are side lengths. There's our x. On the previous one, they were equilateral, so we didn't have to tell which sides they was what because they were all the same. 5 is almost the same problem. Wx and xy are congruent to one another, so you would set those two equal to each other and solve. I don't see any reason to do that one again. Number 6. Flip over there to the back side of that. So here, the difference is that they don't give us a picture. And so it says that triangle PQR is an equilateral triangle. Side PQ is 18x plus 1. Side QR is 24x minus 17. And side PR is 15x plus 10. Find x and the measure of each side. Because they told it's equilateral, what do we know about all sides? They're all equal, so what do we have to do to solve this? Pick 2 of them and set them equal to each other. Doesn't matter what 2. I'm going to do 18x plus 1 equals 15x plus 10. Smaller numbers. So it would be 3x equals 9, x equals 3. And then plug that into something there. So I'm going to do 15 times 3 plus 10. So that's 55. So same problem as number 1 was, just no picture. Number 7 gets a little bit tougher. Whoops. So tough I didn't want to say that. All right. Triangle STU is an equilateral triangle. If ST is 1 less than twice x, SU is 37 less than 5 times x, and TU is 11 more than x, find the measure of each side. Find x and the measure of each side. So we got to be able to translate that into an expression. So ST, what's the expression for it? 2x minus 1. Let's go ahead and do all of those just to get the practice. SU would be, and then TU. Yeah, 11 plus x or x plus 11. Doesn't matter either way there. And then pick your poison as far as setting them up to solve for x. I'm going to use ST and TU. Because it's a easy solve. And then plug that in. 12 plus 11, 23. Easy stuff. Number 8 changes it up just a tad. It tells us that triangle MKL is isosceles with MK and ML congruent to one another. So if MK is 7x minus 15 and KL is 4x minus 5 and ML is 10x minus 42, find x and the measure of each side. So which ones do I set equal to each other? So 7x minus 15 equals 10x minus 42. So that'd be 3x is equal to 27. X is equal to 9. And then we're going to find, we got to find the measures of ML, MK, and KL. So find all those measures. So plug the 9 in to ML or MK. It doesn't, I'm going to do MK. 63 minus 15, 48. Then KL, just need to plug it in. 4 times 9 minus 5. 36 minus 5 is 31. Number 9 is almost the exact same problem. I'm not doing it. Number 10 is a little tougher. So it's got the good stuff there with the translations. Triangle GHI is an isosceles triangle with GI congruent to HI. And then G, H, GH. So let's get the statement for each, or the expression for each one. So GH is 3 more than X. X plus 3, that's super easy. And HI is 17 less than 4 times X. And then GI, which ones of those do I set equal to each other? So 6x minus 45 is equal to 4x minus 17. 2x is equal to 28. Is that right? And x would be 14. And then we need the lengths of each of those sides. I'm going to do GH. Y'all do that. How much is HI and GI? GH is 17, or HG, whichever way you wrote that. It's fine. How much is GI and HI? How much? No. 39 is what I got. Plugging 14 into 4x minus 17 would be 56 minus 17. That's where the 39 comes from. So there's our side lengths out of that. Easy stuff. Easy stuff. Okay. All right. Next. Triangle sum theorem. This is where that 180 stuff comes from. So this is section, or lesson 24. Angles and triangles. Measure of all 3 angles on the inside of a triangle add up to be 180 degrees. You guys already know that. It's not anything new to you. Exterior angle theorem. You may or may not have seen this before. I hope you have. It's not very difficult. The exterior angle theorem just says that the exterior angle on a triangle is the sum of the 2 remote interior angles, or non-adjacent interior angles. Another way to say it. So non-adjacent means not touching that angle. So we go to the outside angle. So angle 1 is the sum of the measure of angle 2 and the measure of angle 3. So proof of that would be, what do you know happens with this angle 1 and this angle? It's not numbered here. They're a what? They're a linear pair, right? So what do we know about all 3 angles? They should add up to be 180 on the inside, right? So if a linear pair adds up to be how much? 180, the same idea there. So there's different ways of getting around to it, but the shortcut is the remote interior. The remote